Sorry about the last video, got a bit cut short, but so 1700,000 minus 1,080,000 equals ASC required times 320 minus 12. 320 minus 12 is 308. 1700,000 minus 1,080,000 is 620,000, so that means AS required equals 620,000 divided by 308, that's 2,013 millimeters squared. So using the tables as provided in the notes, say use 4 bars minimum, then provide 4T32, AS provided equals 3217 millimeters squared, which is greater than AS required. It's close to 4T25, the AS required is close to 4T25, but it's just over by about 50 millimeters squared. AS required is 2012, but need more. So in practice, whether you could get the load down a little bit just to bring it down to 4T25. So for detailing purposes, so here's I just drew out the section of the column to show what it would look like. So bar mark 01, we'd have 4T32 around the edges, and then a link to hold them together. The cover would be determined by site conditions, links covered in another video, and concrete grade is, what was it, 30. So that's B over D. Just zoom out a little bit. D over B. So figure 1 above, diagram of the section, not to scale. 4T32 is the solution provided, 3217 millimeters squared. Figure 1 above, diagram of the section. So also other solutions, we could use 6 or 8 bars, anything that's symmetrical. Say 6T25, then the AS provided would be 2945, or for an example 8T20, then AS provided is 2513, which is greater than 2012. So 8T20, then AS provided 2513. So that would look like this. Bar mark 01 would be T20, so I have 1, 2, 3, 4, 6, 7, 8. So that it's drawn a bit rough because it's in Word, but they should all be like equally spaced and around the perimeter, all the same size, and then 02 is links, not covered in this video. D and B are the same, 300 millimeters. So also consult the spacing requirements in BS8110 for detailing. Just a reminder as well, the little notes were gamma material for steel reinforcement is 1.05, gamma material for concrete is 1.5, and the 0.67 is not a material for safety factor. Okay, so then back to the notes, the original lecture. It goes oh yeah, so then it says when loaded 2.3, this should be 2.3, when loaded by beams, short base columns that support an approximately within 15% symmetrical arrangement of beams can be designed using NUZ equals 0.35 FCU AC plus 0.7 FY AC ASC. For a rectangular section, this is equal to NUZ equals 0.35 FCU BH plus ASC 0.7 FY minus 0.35 FCU. So then it says redesign the previous problem for the case when it's loaded by such beams. So basically it's reducing the allowable stresses because of the beams. So back to I've done the solution for this as well. So we just, when loaded by beams, short base column that supports approximately within 15% symmetrical arrangement of beams can be designed using NUZ equals 0.35 FCU AC plus 0.7 FY ASC. For a rectangular section, this is equal to NZ equals 0.35 FCU BH plus ASC 0.7 Fy, 0.35 FCU. Call this equation 2. So let's replug in our values into this equation. We've got 1700,000 equals to 0.35 times 30 times 90,000, which is BH. FCU is 30. ASC required times 0.7 times 400 minus 0.35 times 30. So 0.35 times 30 times 90,000 is 945,000. 0.7 times 400 is 280. 0.35 times 30 is 10.5. So 1700,000 minus 945 equals to 269.5 AS required. So AS required equals 755,000 divided by 269.5 is 2801 millimeters squared. So basically it's gone up. Compare the 2,802 millimeters squared now required to 2,012 millimeters in the first example. So the amount required has increased. Using the tables I provided in the notes, use say 4 bars min, then provide 4T32 AS provided equals 3217 greater than 2802. Now it's nearer to 4T32. The required AS has gone up. Refer to the diagram above. So we could use the same as we did in example 1. We could use 4T32. That would still be alright. This solution, or just to give a variation, we could use 6T25. That from the tables that provides 2945. Okay, so it would look like this: 1, 2, 3, 4, 5, 6. I think that's another solution. I'll double check that looks looking okay. So that completes section 2. In the next video we're going to move on to short brace columns resisting axial load at moment.